Welcome to the part 4 of the tutorial. We continue to develop our Space Invaders arcade game on the HyperPET Pico. In this tutorial we will address more complex graphics being bitmaps, so full screen bitmaps. But before that we will also learn how to create fonts and use fonts. So far we used basically the sprite layer for the Space Invaders. We use the tile layer 1 for the star field. I also added offline the shield, so the shield over here also on the tile layer 1, so the upper tile layer. And what I would like to show is how we can also display text in the tile layer 1, because as you have probably seen before, you have basically two layers in the background layer, which is the color background layer. You have on layer 0 you can have tiles or bitmap. We will display a bitmap soon. But in layer 1 you can have the PET font or you can have the tiles, but you cannot have both at the same time. So here I have chosen to go for the tiles. So if we want to have font on the layer 1, we also need to make it part of our tiles. So since last time I also improved a little bit the movement of the Space Invaders, and as I said, I implemented the shield. So we will continue from that, and I will show basically the status in a few minutes. So, but before we start, let's go to a website. So there are many websites where you can find a font, because the font format of the PET is basically the same as the one of the C64. So if you go on this website, you can find a set of font. As you can see, we are only interested in the first, so there are 32 characters per row over here. We are only interested by the first 64 characters of the font. The rest doesn't matter too much. So I have decided to already load one of these fonts. So if you just click on the file and you go to the file, you will see such a file. It's basically a font which is 1 bit per pixel. So, and you often have some offset. So I don't know exactly. I think this is just the size of the font. So you can trunk this, save it, for example. I see also there is a 78 at the end. I don't think this is very useful. So this is just how you can take a font from the internet to use it on the HyperPET Pico. So we'll try to use it. I saved it. I will copy it over here. I will call it the 7up font file. Doesn't matter too much. And I will copy it in the source tree. HyperPET. I will copy it into the tutorial directory. So we are at tutorial number 4, and I will just copy the font from there. To here. So the font you can integrate it as a bin file. I will copy again from my cheat sheet font. I have here. I can integrate it at the end of everything, and I call it font. Let's use that font that we called. How did we call it? 7up. Yes, 7up font. Okay, we save this, and then at the place where we are programming the tiles, we are going to add basically an extra copy. So we can go back to the place where we programmed the tiles, which was that place. So what we had defined so far 2 tiles, one empty tile, which is the tile 0, and then the first tile being the tile that we use for the star, which was that specific vertical line in different colors. So this is this one actually here. I have changed slightly the offset because the font will take 64 characters, so I decided to move basically the tiles that we define, I decided to move to 40. So here we have our 2 tiles transfer. These were normally in 2 bit per pixel. The font will be 1 bit per pixel, so we can, after that one, we can also just add here the transfer of our things. Yeah, I also added 12 extra tiles for the shields. So that means that in addition to the 2 we had before, I also added these ones. This is represented by 6 tiles. And in fact, it's not 6 tiles, it's actually 12, because you have every time the shield being non-touch and the shield being affected by bullets, so it's partially destroyed. So every time for each of the part of the shield we have 2 bitmaps. So this is actually 12 tiles. So it's transferring. So this is also 1-bit CLUT, so we already set up the 1-bit CLUT. So the only thing we have to do is after this, so this is plus 12, so this is really 12 tiles that we use for that. So before this, so because that starts at 40, doesn't matter actually the order you do it, but here we are going to copy our font at the beginning of the tile set. So I will go again over here. Yeah, these are actually the tiles of the shield. So tile 1-bit definition, these are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. This is the part of the shields that are there. But we will now copy the font, so we need to add just something which is going to copy, small routine that will copy the font, and I have it already over here. I'll take it from here, and I will paste over here. So we go, so the font will be 1 bit per CLUT, so we select the depth as 1 bit per CLUT. We take the start address of the font, and we use the command to transfer font data. We have to transfer it as tile, so we specify the size of each tile, which is 8 by 8, and then we copy. We have a loop to copy everything until we arrive at the font end. So when we have that, normally we should have our font being copied. Now to show the character map, what we can do is at the beginning of the code, I will just adapt the code here, and I will just print. So this is just setting the video mode, programming the sprite and the tiles. Forget about what is on top, I will explain that after, but here I will just wait for a key. I made a function called press space, which is waiting for the space key to be pressed. So I will do that, but before this I will display on tile 0, I will display on the layer 1, I will display all the tiles that are currently programmed. Then you have an ID of what is currently defined over there. So I just have a small loop, and what we do, we display on tile 1 map. We'll display all the characters actually from 0 to 55 in this, so we will show on top over here all the characters. So I will save this. Before maybe I flash the new image, let me show you what I did previous time. So what I implement is the movement of the Space Invaders in such a way that you can now have the stars, but you can also shoot the aliens. You can move, and the aliens are moving also from top to bottom until they land on the shield, and then it's the end of the game. But the bullet can also shoot on the tile. So there's no collision mechanism on the HyperPET Pico to detect collision between the sprites and the shield, so you have to handle that. You can look in the code how it is done. So the rest is basically moving the object compared to what we did last time. So I will just compile what I just have here, and I will program the whole thing. Let's compile our example. So reset it and try it. So now we should see, something went wrong, as you can see. Let's look back at the font. Yeah, it has to be a multiple of 8 and it is not a multiple of 8, so there's one character too much actually here in the font. So 1 to 31, I think that would be fine if I do it like this. Let's compile it again. So I didn't change anything in the code over here, it's just the font size, which has to be a multiple of 8 bytes, and it was not. So we compile it again. No need to reset. So this is what we have now, but don't forget we also need to set the tile mode. So to be able to see, of course, the layer 1, I also need to activate it, so it's not enough to go to that resolution, so I will just here add this, then I can compile and we can finally see okay, so this is the tile set. So the first 32 characters, so that's 32 characters per line, so the first 64 characters are coming from the font. Then we have the bullet that we defined last time, and then we have the tiles that I use for the shield. So it's every time one tile, the same tile destroy, another tile, the same tile destroy, etc, etc. So that's how you can actually add font to tile layer 1 by just making it part of the tiles, basically. So that's our tile definition. So now that we have this, we can also display text. So to display text, I created a small routine which will basically use the font to draw some text, and I created a routine which I called which is called print. So the part of the code normally over here, and that routine basically it will take as an input, it will take text, and the text you will format it like that. So you have basically an array of bytes. The first 2 bytes are the XY position of the text where you want to display it. So you have normally, in this case, 32 by 25 characters. So at position X being 12 and Y being 15, we will display this text. The 0 means it is the end of the string. And then you can link again new text after, so you can put another coordinate, in this case at 12, 16, xy. We will display that text, end of string being 0, etc. until we define the character ff. So the small print routine is going to take this buffer as an input, and it will parse it and basically print on the screen the string which are defined at the coordinates that we have defined over here. So if we call this routine, it will basically print this text. Just a small detail, there is normally a small table which is called init line offset, which is basically a small table which contains the offset per line. So to avoid to multiply by 32 and add, I predefined. So for this is actually a table which will contain the low byte and the high byte of the address in the tile map, an offset actually, to define the position at each line. So to avoid to multiply by 32, that will just basically give, if you pass the y being, for example, 5, it will go at 0, 1, 2, 3, 4, 5, and it will give these two as a high and low offset to the tile map, just to speed up the print routine. It's just some optimization, don't need to understand. And this table is initialized by this routine init line offset, so it's called before the text is is actually printed. You have to initialize this table. That's the line that was at the front over here. So before here, just the same moment we initialize the tiles and the sprite, I also call this just initialization routine to compute these offsets before you start to use it. So then we will initialize, and so then the only thing that needs to be done is to load the text. So I will also copy it from here, so the font we don't need anymore. I will copy it from here. This is how you basically have to use the routine. So you have to store the low and the high byte of the address where the text is. So in this case I call it title lines, and then you call the print routine, and then we'll wait for the space key. So if I now compile this, we should see our text being displayed using our font. So this is already not so bad. We have some text. I think it's not fully centered, but doesn't matter too much. So now what we want to do in addition is to display actually a bitmap. So this is rendered in layer 1, and layer 0 currently we configured it to be such that in layer 0 we don't display tiles, but we display a bitmap, but we did not define a bitmap. So to be able to define a bitmap, you first have to choose a bitmap. So to be able to convert bitmaps, you will need a tool which is defined over here, PNG to PET. And the first thing you need to do is to open a window, go into this location of the tool, make it, build the tool, and when we have the tool we can use it. How do we use it? If you use it, you actually need just one parameter, being the image without the extension PNG, and then the resolution at which you want to convert the PNG for the format of the thing. So again, normally on the HyperPET Pico you have 3 possible resolutions. The first resolution is 80 columns, so that's basically 640 by 200. You have the 40 columns mode, which is 320 by 200. In these two modes, the resolution of the bitmap in background in layer 0 will always be 320 by 200. But we are using the third resolution being 256 by 200. And because we use that resolution, the bitmap will be at 256 by 200. So here we will have to pass, if we convert the bitmap and we want to show it here, we will have to convert it to 320. So PNG to PET, we'll have to choose our bitmap, and then we have to define it at 256 by 200. So we just need to find out the bitmap, and I have over here, I have found some interesting bitmap for the Space Invaders. I found a PNG. This is the PNG. So the PNG don't need to be at a particular resolution because the PNG to PET is going to scale down the image, and it will also do dithering. Currently it's by default deterred, so I can modify the tool to not to do the dithering, but there are only 256 colors. We use the RGB 322 mode, so if we want to convert and have good, let's say, quality, we better use dithering. So that's the PNG. So the PNG currently, I don't know if I can see it over here. I think we can see it over here. So the PNG is at 225 by 225. So we will just convert it. So we will take this as an input. So SI and no extension. It will use by default a PNG, and it will create few files. There will be a GIF which will just be there as a reference. Don't need to know. There are two files which are actually the raw format of the PNG. So that will be basically, in this case, 256 by 200 pixels. So that's 64,000 pixels. That will be saved. Sorry, not 64,000 pixels. You can see it over here. That's 51K. And that's after the dithering. And then it will generate a file which is called SICRU. This is actually using the great compression tool which was developed for 8-bit computers, and the tool is used. It's called PuCrunch. So if you go on the PuCrunch website, we can try this. If you go here and you search for, let's say, C64 PuCrunch, you will end up on a fabulous tool, which is here. And it's basically a compression tool for the C64, which is nice because it doesn't take too much footprint. So you can actually use it to decompress on the C64, but we will not do that. So the way the bitmap are transferred to the HyperPET Pico is that you embed into your program the compressed bitmap, and when you transfer it to the HyperPET Pico, that's the Raspberry Pico which is doing the decompression. But you can also use it on the C64. I have an example of that. The problem is that you have only 32K of RAM, and the bitmap will be like 64K, so you cannot embed, let's say, a full screen bitmap in a program. If you decompress it, it will take more space than the RAM you have available, so you better decompress it directly on the Pico. But if you have like a compressed bitmap which is few K, you can always decompress it on the C6502 code. So it's using this decompression on the Raspberry Pico, and we will compress it for that format. That's the CRU format. So you can see actually that the bitmap, which was originally as a row, it was 51K. It's now as a GIF, it would be 7K, and here it's 6K. So this compression routine is quite okay. So I will do that. I will also take another bitmap. We can also convert it right now. I have found a nice bitmap that we could use to actually use as background during the game. So the first bitmap we'll use for the title, and the second one will be used during the game. So I found a linear background. We'll also convert that one. While we are here, we can just convert it as well. Same resolution, linear. And it will create it. So you can see that the original bitmap as a row is 51K also. And as a compressed, it will also take 7K. So we'll have 7K and the other bitmap being 6K. So we have 13K of compressed data that we have to embed in our program, but that still fit in 32K. So we will just copy these two. We will copy it into our program. We go to the tutorial here. I will copy them both. So we have our font and we have our program. I will copy it here. And now we can embed the bitmaps as well in our program, and we will try to display it. So where we display the title here, we will also display our bitmap. How do we do that? First of all, we will embed the bitmaps. Again, I will embed it as a binary. I have the example over here. I will just reuse this. Like we embed the font, we will embed the bitmaps. Save it. And then actually I have already the code over here. If you want to transfer a bitmap, I will uncomment all this. I create a small routine for it. So there is a dedicated transfer version. So again, all the graphics, objects, tiles, sprites, etc. you transfer them into the graphics memory of the pico using these transfer functions. So in case of a bitmap, first of all you have to indicate that you transfer it as 8-bit data. In this case it is packed, so you don't have to interpret this as RGB, whatever. It's just compressed data in this case, so it's just bytes. Then you use the command 8 to transfer a packed bitmap, so the bitmap is compressed and you want to transfer it to the pico, and it will decompress it into the layer 0 bitmap memory. You define a start address, so that's just this, and you will copy. So the only parameter that you have to pass is the size of the compressed bitmap, so which is the bitmap n minus the bitmap start. You take the low byte and the high byte, you put it as parameters, so you first send the command 8, then the parameters being the size of the bitmap, 2 bytes, and then you transfer the data. So you have a loop that will just go there. So that will just copy the bitmap, and at the end it will wait until the decompression is done. That's also important to know. And I create another function for the background, the other lunar background. So that's what I call the game bitmap. That's the moon background, the second background. And so how do you actually wait? You just load the status registers and you wait until it becomes 0. So when you send a command, this is like an asynchronous command to the HyperPET Pico that is going to decompress the bitmap. If you use this, you have to wait until it's finished. So if I call this function, show title bitmap, we should see our bitmap being displayed in layer 0. So we have our text. We set up first our layer for showing, hiding the sprite in this case, showing layer 1 being tiles, and showing in layer 0 the bitmap. So I will just call this function. And then we will press space. And we should see our bitmap. Let's hide this. Let's compile. And voila, we have our Space Invader logo being displayed. So as you can see, it is tethered. So you see some mixing of colors to reach the yellow color, for example. And then if we press space, we go and we will now also see our lunar background, which is here. Yeah, I didn't mention, but it was already in the code. Over here, I was already doing it, so here I'm showing the game bitmap after I press 0. In fact, this code that I added at the front is now useless because it was already here, so I can just remove. Actually, the code was already here, just behind. The only thing that was not done was basically to press the space key, so I can add it. Over here. Voilà, so that's our program. We have learned how to display bitmaps and compress them using this PU cruncher, the PNG to PET tool, to make some nice graphics. So now we have a great Space Invaders game. Let's recompile everything. title screen. We press space to start, and we can play our Space Invaders. I'm trying to implement the scope on top, but it doesn't fully work, so something will come back to it. So I think the last tutorial we will have will be to add sound to our Space Invaders, but for the rest it's already usable. Well, that's it for this tutorial. We have learned how to display strings basically using a font and basically show bitmaps on the HyperPET Pico to enhance the graphics. Again, something I mentioned at the beginning, all the graphics in the HyperPET Pico are stored as in 256 colors. So the challenge is always to be able to define nice graphics and to store them into the 32K of the PET. So this packed mode, which I use now for the bitmaps, you could also use it for sprites and for tiles. I'm currently have added in the API a way to transfer packed tiles and packed sprites, but I didn't try it yet. We can also try that in the next tutorial. So it allows to make graphics basically in more colors than like 1 bit or 2 bit or 4 bits per pixel, and to still be able to store them into your program at the PET side. That's it. See you in next tutorial.